So you've designed this beautiful tile map for your game, but you have no interaction with it. A player walks across it and there's nothing that they're interacting with while they're going through it. Or you want to be able to change that tile map while the game is running. How do you do that? Today we're going to go into how to interact with TileMapLayers using code. We're going to cover some basic reading and writing so you know how to interact with it, primarily focused on working with a mouse, but you could be using any sort of input source. Hi, my name's Brian, I'm a software developer, and I'm pouring that love of software development into building accessible video game tutorials for you so that you can build the games that you want. Let's get started. Before we start interacting with our tile map layer using code, let's cover some basic fundamentals first. Every tile map layer has a tile set, and so this is a collection of tiles that we have that we can interact with and paint on our tile map layer. Each tile set has a number of tile set sources, and so this can be an atlas, which is essentially a sprite sheet, or it can be a scene collection. Now, whenever we're referring to a particular tile source or an individual tile, we're using some sort of reference ID to interact with it. So the first thing to keep in mind is the tile set source, and so that's this tile source pane here on the left hand side under our tile set tab, and we can see that this particular one has an ID of 0. If I was to add a new collection here, I'm just going to add this tiles.png, which has been created. We can see that it has an ID of 1. So that lets us differentiate between which tile source we're working with. If we were to bring in a scene selection, we would have yet another incrementing ID, and we would just interact with it as if it were an atlas as well. Now, in order to refer to a specific tile on a tile set source, we would use its atlas coordinates. And we can see this by selecting this select pane here. And if we click on an individual tile, we can see the atlas coordinates listed here. This is always going to be the top left corner of a tile. And so if you have a tile that is different than its 1x1 default size, such as a 2x2 or a 3x2, like you've got a particular like a house asset that you wanted to drop in all in one fell swoop, it's always going to be that top left corner that you're referencing there. So that's something to keep in mind as well. Now, if we're interacting with scene collections, because a scene collection is just a list of scenes, there is no coordinate that we would be using for that. So instead of using the atlas coordinates, we're going to use the alternative tile ID in order to reference a specific scene in a scene collection. We'll see that come up momentarily. Let's get started with just the basics here. So how would we set a particular tile using code? Let's start first by creating a new script that we're going to attach to our main scene here. So I notice that I've selected the square tiles. I don't see my tile set and my tile map at the bottom here. And we're going to add a new script to this just by clicking the add new script button, and we can call it the default name. If we want to set a particular tile at a particular coordinate, we need two things. First, we need to know which specific tile that we're working with, and there's a few pieces of information we're going to need to gather for that, but we also need to be able to reference our tile map layer itself. We're just going to do this on ready for the scene because we don't care about any sort of interactions with it. Let's just get the basics in, and we can always extrapolate based on that. So I'm going to create a new function that references the ready method here. Now we can simply click and control drag the tile map layer up top here, and this is going to create a variable reference here. Rather than us having to constantly do the $tilemapLayer, which is dependent on the name, we've got a reference that we can always update, and it's easier to keep in sync. We now have a reference to the tile map layer itself, and we can use the setCell function on there in order to change the tile. Notice that setCell is prompting us for a number of pieces of information. First, it's prompting us for the coordinates of the cell that we want. And so this is where on the 2D scene we want this to sit. If you're looking for a particular reference, you can always hover over your tile map layer in the 2D view, and you can see in the bottom left corner of your 2D scene here that there's a set of two numbers that updates depending on where my mouse is moving. So if you know exactly where you want that to be, you can always target that. I'm going to target 3,4 here, just as an arbitrary value that I'm going to pick. If we hop back into our scene, that's what it's prompting us for here. So we can create a vector 2i with 3 and 4. The next piece of information it's prompting us for is the source ID. And so this goes back to our tile set and the tile set source. If we look at our terrain_square.png, we can see this has an ID of 0. We can simply put 0 here. The next piece of information it's prompting us for is the atlas coordinates for what specific tile we want to display in that tile set source. So if we come over to the select pane here, and I'm going to pick this particular tile here, arbitrarily, this happens to be sitting at 3,3. And so we can create a new vector 2i of 3 and 3. And now this final variable is the alternative tile. We don't have any alternative tiles, we don't need to worry about this, and so we can simply omit it. We can tell that we can omit it because it's prompting us for a particular value. It's telling us the data type is an integer, and it says equals 0 at the end. And so what that says is if we don't provide a value, it will assume the value is 0, and that's what we want. If we run this, we can see that this particular tile has in fact updated to the new value that I set. Now you're probably already starting to sense some of the pain of having to keep track of all of these numbers, or all these variables and what they actually mean. What does a vector 2i of 3, 4 mean? What's the significance of that? Or this 0, or this vector 2i of 3, 3. Now some of these, yes, I just arbitrarily picked them, but when you're doing this in a game, those values matter. They matter for what they represent. So this 0, really what this is the tile set source that has both grass and sand on it. So what I can do is I can create a constant that names that, and then I've got a reference that I can constantly refer to that reads as English, not just as an arbitrary number. So I can say const here, tile set source, grass and sand. It's an integer, and it's going to be 0. And if I replace this number here, now I can look at this and I can go, right, this is grass and sand. Now this might be a little bit too wordy. We can trim this down and say, maybe we just call it source grass and sand. I think it's worth putting a prefix on the front of it because you don't want to reference this in another place and have it mean something else. So being able to say this source is grass and sand, so that kind of gives this key value definition there. We can do the same thing with this vector 2i. This vector 3, 4 we're going to leave as is for what will become obvious reasons in a moment. But we can say const grass and sand. I'm going to call it circle. It's a vector 2i. And we're going to say that it's at 3, 3. And now this provides a little bit extra context when we're actually interacting with things. If nothing else, this makes your code easier to understand, especially when you come back to it in the future. While we're having this discussion now, and you kind of know in your head, yes, well that was 0, it's much shorter to write 0. Sure, that's a fair point, but when you come back to your code in a month or 3 months or a year, how are you supposed to remember what the vector 2i of 3, 3 actually meant? So put some context behind that constant name. What you don't want to do is call this vector 2i 3, 3. This really isn't any better. It doesn't provide any context. What your constant name should be should reflect the context of what it means, not just what it is. What it is isn't particularly relevant. What it means is. If we run this again, nothing should have changed. And in fact, we can see that that value is in fact still getting set accordingly. So this code on its own isn't particularly useful. We could have just set this in the editor. We didn't need to write code for this. So where do we take this? Well, a good starting point could be clicking to paint the particular tile in a particular location. How would we do that? Well, we already know how to paint a tile at a particular location. So we need to figure out what that particular location actually is. We also need a way of detecting that input click. So how do we do that? First, we need to define a new input. So if we go over into our project settings, into our input map, we can create a new action name. So let's call it paint tile. And if we add that, Again, we're putting context into here as to what it means, not just that it's a left click. It may not be a left click if we were using a joystick, or if somebody changed the inputs to be something else to be a little bit easier for them to use. So let's call that input what it means, and then we can assign the input mappings based on what we want our defaults to be, but we could always change them at some point if we needed to. So we go down into our paint tile, we can click the plus sign, and let's just do right click. And so the right mouse button will come up here. I'm going to hit OK and close that off. When we want to accept that input, we now need to tie into the input function that exists on all nodes. And this accepts an event as its one parameter. Now, this input event is what we call an abstract base class. So you would never instantiate a new instance of an input event. Instead, there would be some type of input event that extends that and is providing extra input for us. So we first want to detect if we've got our own input event getting passed in, the one that we just defined. And so we can say if event.isActionPressed. There is an isActionReleased, and sometimes that's something that you would want to do instead. In this case, we're just going to do it on ActionPressed, and we have our paint tile action name here. Now, at this point, again, there's not a huge amount on a input event. We have a device, which we're not really using at this point. Instead, we need to use something that is defined on some other type of input event. Now, the specific type of input event that we'll get for a mouse button click is an input event mouse button. And this extends input event mouse. And on here are our global position and our local position. And this is something that we can actually start working with. So we have confidence at this point that this event, if this particular statement is true, that we are pressing the paint tile event because we've only defined it as a mouse button click, we have confidence that it is going to be that. And we could go so far as to say that we assert that. So we can call assert, and if this statement is not true, then it would crash. So we can say event is input event mouse button. We have confidence that that's going to pass. Because we know that it's an input event mouse, an instance of that, we have our positions and we can comfortably work with those. So let's just grab the local position and extract that out into a variable to work with. So we're going to say mouse position. This is going to be a vector2. And just grab the event position off of that. Now, in order to translate that into the coordinates for our tile map layer, there is a helper method that all tile map layers provide. We can say var local coordinates. I'm just going to abbreviate that to coords. Now we reference our tile map layer here, tile map layer, and we can say local to map. So this takes a vector2, which will be our mouse position. And just a quick look at the documentation for this. So this says returns the map coordinates of the cell containing the given local position. Now there is some referencing to global coordinates. So we're going to put a pin in that. We're going to come back to that in a moment. That is going to become important though. So this local coordinates now should be the location on our tile map where our mouse clicked. And so if we were to, instead of providing a hard-coded vector2i, we should just be able to bring that down here, replace this vector2i with our local coordinates, and get the desired result. Let's try that out. So with our game loaded up, we right-click. Fantastic. Wherever I click, we get that popping up. Perfect. Now there is a little bit of a problem with this, and unless you are changing some particular properties on the tile map layer, you wouldn't notice it. If we take a look at our tile map layer right now, we take a look at its transform, you can see that its position is 0, 0. So its origin is exactly the same as its parent origin right now. What if that wasn't the case? What if it was 200 pixels to the right and 100 pixels down? What's that going to look like? So again, if I right click here, well, that popped up not in the right spot. Can I try that again? Hey, everything looks like it's about offset by that 200 pixels to the right and 100 pixels down. Well, what's going on here and how do we correct this? Well, let's pay attention first to where this input event is occurring. So this input event that we're tracking here is on our node 2D, specifically the parent scene that we have, this square tiles. And so the position that we're working with there is actually going to be relative to the square tiles root node that we're working with, not the tile map layer. So this mouse position here actually has no concept of the relative position of the tile map layer. So if this is 200 pixels off to the right, there's nothing in here that's accounting for that. This is assuming this local to map function that exists for tile map layers. It assumes that you're working within the local coordinate space of the tile map layer, not the global coordinate space of the scene itself. So the easiest way to deal with this is to simply use our tile map layer to convert to local coordinates and instead work with our global position instead. So if we take our mouse position here and we take the global position rather than the local position, we can then utilize a function that exists on all node 2Ds, which lets us convert between global and local coordinates. Now we do need to do this within the scope of the tile map layer, not within the scope of our general scene, because there is no offset on our general scene. So if we say tile map layer dot to local, and we can pass in our mouse position then. And so that gets us first the global to local translation from global coordinates to the local coordinates relative to the tile map layer, and then gives us our regular coordinates that we would be working with for accessing a specific tile. Let's try that now. Now that we've loaded this up, I right click and everything is back in sync. I've personally found it simpler to just work in global coordinates and then go through this translation. It makes things a little bit easier in my head rather than having to worry about local positions everywhere. I just tend to operate purely in a global position perspective and then translate down as required. Another way of addressing this though would be for us to have the script not on our square tile scene, but instead on our tile map layer scene. So if we had instead created a script that was specifically tied to this tile map layer instead of the square tiles, then the input event's position would be relative to the tile map layer itself, not relative to the square tile scene. And so that translation from global to local coordinates would have already happened for us and we wouldn't need to do this extra level of work. There are pros and cons to that. Ultimately, it comes down to whether or not this logic of right-clicking on the tile map layer, where does it belong? Who should really be owning that logic? Should it be owned by the tile map layer itself, or should it be owned by the map that you're working with? In which case, that might be the parent scene. That's really a design question at that point, and there are pros and cons to each. So ultimately, you have to be the one that makes that decision, and there are trade-offs for both of them. Now the logic that we've implemented here works just fine for atlases. It doesn't work for scene collection sources. So how do we deal with something like that? Well, just as a refresher for what a scene collection is a collection is a tile set source. This is a collection of other scenes that you treat as if they are tiles. So that can come into play if you have something that's a little bit more complex and then you want to be able to treat it as a tileable resource. That's a way of dealing with it. There are a number of pieces of functionality that don't exist for scene collections that we're used to having with a tile set, such as the animation and rendering and terrains and all the kind of the mass painting stuff that you get with an atlas. Instead, you're responsible for putting that onto your scene itself. So there are trade-offs to that. But let's say you do end up using them. Let's create a new scene collection here. I'm just going to drop this in. and I'm going to very quickly create a basic new scene for an example here. Okay, so I've just created a very basic animated tile here just for an example, just so we can tell the difference between this and another tile that I would have painted. And so if I come back to our square tiles here, and in my empty scene collection, and I go to our tile set tab here at the bottom, I can add that scene here and have it available to interact with. And I can just paint this on as I would any other tile. So I've got that available as an example to work with here. So if we were to interact with this using code, again, there are a few things that we need to remember. One is we need the scene collection ID. In this case, it is scene collection ID 3. We've got it available here. It also shows it here for us as well. Let's define a new constant for that. So I'm just going to say source needed scenes. And then we also need an identifier for this particular scene tile that we've created here. Now this currently has an ID of 2, which isn't a vector 2i. So what the documentation says for working with set cell for scene collection sources is that we use the alternative ID and set the vector 2i for the tile map coordinates to be just a vector 2.0. So we're going to define a constant. So this will be animated, scene will be an int, and this is an ID of 2. So again, if we were to redefine this, let's just comment that out. Again, we reference our tile map layer. We want to set the cell on it with the local coordinates, which is where we're targeting. Our source, so this will be source underscore animated scenes. We'll set a vector to i.0. Now it is important that we set something there. If you don't set something, it can blank it out. And then the alternative tile is going to be our animated scene. So if we try that, right-clicking now shows the animated tile. Great, so we've covered the basics of setting a tile on a tile map layer. We know how to take global and local coordinates and translate them down into coordinates that we would work with. And this works the same regardless of whether or not you're using square or hexagonal, isometric versus half offset square. Exactly the same for all of them. The exact same logic still applies for all of these. It's not any different. What if we wanted to read data off of this though? So let's start with just seeing if we can detect if there's a tile in our current position that we click on. So we have some logic already for being able to detect if a click happens. We're going to create a new action just so that we've got some separation here because we did call the action paint tile, but we know how to get the coordinates there. And now we have to think about how do we actually read the data off of that tile map layer. Let's take care of the parts that we understand first, which is creating a new input. And so we go into our project settings, into our input map, and we're going to create a new read underscore tile action. We're just going to set this to the left mouse button. We also know that we need to declare an is action pressed statement. And so in order to separate these out, we can say ELIF. So this is an else if. Now we could also just do if here. However, one of the problems with this is just an efficiency thing. If we were to run the is action pressed for the paint tile and this occurred, there's no reason for us to run the read tile because we're not triggering both a paint tile and a read tile input event at the exact same time. So we're just going to say else if in this case. We also know how to get the mouse position and the local coordinates. So let's grab that information right now. We can take this exact same code and move it over down here. Now we have to actually read the data off of the tile map layer. So the most universal way of detecting this information is to check the cell source ID. And so if we look at tile map layer, we have a get cell source ID, and this takes a vector 2i, which is our coordinates, which we can just pass in these local coordinates, and this will return a number based on the source ID that was previously defined. So if we look at our terrain square here, it has an ID of 0. If we clicked on one of those, we get 0 back. This particular one that I just added here has an ID of 1. We would get 1 back if we clicked on one of those tiles. Same for this scene collection source. We have an ID here, we get 3 back. Now, if there's no tile present, if we look at the documentation, it says that this will return -1 if that cell doesn't exist. So what we're really looking for is if the value that's returned is not equal to -1, that means that there's a cell present there. So we can say if the source ID for that is not equal to -1, we can just say print tile exists. And we'll just dump this out into the log. And if it doesn't exist, then we'll write that out. So if we try this, we clicking out in the void here, the tile doesn't exist. If I click in here, now we're getting tile exists. Now let's say we needed to actually read information off of the tile data. How would we take care of that? Well, we do have access to tile data again on the atlases, so we could look at some of the information that was here if we had the probability information that we needed to access, or we had defined custom data here. So if we had custom data layers which had an impact on how much damage you took when you walked over that tile, or marking it as difficult terrain so it has a movement cost associated with it, those might be things that we would put on a custom data layer. So let's actually create a custom data layer here. We're going to say movement-cost, and this is going to be an integer. Then I'm going to quickly define that for everything in our terrain square right now. So I'm going to hop over into our paint tile here, movement cost, set these all to 1. And I'm just going to quickly paint over all of these so that we've got them properly defined. And then I'm going to pick 1 or 2 that we're going to make sure that are on our map so that we can actually have a higher movement cost on them. So we're going to set this to 2, and it looks like some of these edge pieces we have existing here. We're just going to say that the movement cost for those is a little bit higher. So how do we read this information? Again, remember this only applies to atlases, but we have access to that via the TileMapLayers get tile data. So we can say TileMapLayer.get cell tile data. Again, this takes local coordinates and returns tile data. I'm just going to call it data here. And we can move this into our tile detection logic. So we can say if the data exists, so we can say if it's not equal to null, then we can start interacting with it. So we could say data.get custom data, and it's going to ask for a layer name. Our layer name is what's defined here in our custom data layers here over on the side. So this is going to be movement-cost. Now get custom data returns data as a variant. So the data type here isn't known at compile time unless we enforce it. We know what it is because we can see the custom data layer, but really this could hypothetically return anything. We don't have full control over it. So we can type def it. We can say as int, that enforces it there. We can also drive it based on the variable that we assign it to. So we can say movement cost and say that it's a type of int, and therefore we've got some enforcement as to the data type that it actually is. And we can now print this out if we have it. And so now if I click here, we can say the movement cost there was 1. And I click over here, the movement cost here is 2. Now if we click off on the side here, again, there's no tiles there. We're not getting any output. We can see that because this get cell source ID is going to return -1 in that case. Also worth noting is that if I right click and I put one of these animated tiles, remember this is a scene. This is not an atlas. If I click on this cell source ID is going to return true, but we're never going to get any data coming through. Cell tile data only exists on atlases. Now that we have the tile data, we could just read the information off of it. We could read information about its physics or terrain layers, its custom data layers, or anything that we had specified on there. But what if we wanted to modify that at runtime? We can do that. We have the ability to update this tile data should we want to. Tile data is editable just like any other resource that we have here, and so we could make changes to things here if we want to. Now, it's worth noting that when we do make changes here, we're changing every single instance of that tile on the tile map. We're not targeting a specific tile in the entire tile map layer. This was something that I really struggled with when I was trying to learn this, was I wanted to kind of apply custom data to a very specific tile. Not every instance of this bush in the scene, but this one specific bush. And tile data just doesn't handle that. Tile data is a property of the tile set itself, not the tile map. And I think that's an important distinction to make. When we're making changes here, we're impacting all instances of that tile across every place that is using this tile set. Right now, that's just this tile map layer that I have defined here, but it could be every single instance of this tile set across your entire project. You could be reusing this tile set across multiple places in your code base, and probably you should if you're having a big game that has the same kind of tile set everywhere. You want consistency. But if you're making a change at runtime to things such as a bush saying that you should take extra damage when you walk into it or something, what you're really doing is you're changing every single bush within the entire project. So that's just something to keep in mind as we're going through this. So we're familiar with the get custom data method that exists on the tile data because we just used it, but we can also use set custom data. So we can apply whatever value we want here. So if we were to go back to our script, instead of writing out this movement cost, we could increase it over time, or we could just set it to 5 arbitrarily. So we're going to keep this existing logic here, and we're going to say data.set custom data. We're going to grab movement cost here, and we're going to set that to 5 instead this time. So if I click on a particular tile, it's going to initially say its movement cost was 2 because that's what it was before I read it. But if I click it again, it's now movement cost of 5, and it's going to remain that movement cost of 5 while I'm clicking on that exact same instance of that tile. Now, if I click on this particular tile here, which was the same tile itself, just in a different place, it's still going to have that movement cost of 5. Remember, we've updated it everywhere. But you could use this if you needed to apply global changes to everything. You might have some problems with state management at that point, but it's totally doable and you can modify these things at runtime. Now, one piece of interaction that we can do that does modify just a single tile is the flip and rotation. That's something that if we look at our tile map itself, if we were to paint here, we have the ability to flip horizontally and vertically, as well as rotate clockwise and counterclockwise. And so we can also do this in code and have that impact just a single coordinate on the tile map, rather than all instances of a given tile. Both are doable. If we wanted to target all tiles in a given tile set, or a specific tile within a tile set, we could use the tile data and we could update that as we had been previously doing. Or if we want to target a very specific tile, we can also do that. So let's hop over into our script again. And so this read tile, I'm just going to repurpose this for now. And we're going to update that information. A good starting place for us to look at is the Godot documentation for tileset atlas sources. And so we can use this information and this sample documentation, the sample code here that they provided, in order to give some easy access to the rotation logic. What we do here is we modify the alternative IDs of the given cell tiles, and we can change the data accordingly. Now, in order to get rotations, what we're essentially doing is we're applying a combination of flipping and transposing, and that's what this enum here is doing here. We can actually just take this code here, copy it, And you can see here that there's this rotate 90 is a combination of transposing and flipping horizontally. 180-degree rotation is flip horizontally and flip vertically. 270, 3/4 of the way around, is transposing and flipping vertically. But we can just copy this. We don't have to worry about how this is being done here behind the scenes because they've already provided code for it. I'm just going to put the example code that they provided up at the very top here, and now we have a reference to it. So we do need to set that cell again. So we need to get a bunch of the information off of it. So TileMapLayer.set cell. So we need to grab the local coordinates, which we have here as local coords. We need to get the source ID. Now we could grab it from here. We can just copy paste this exact same code here, drop this in. Atlas coordinates, again, we need to grab those atlas coordinates. So we can say TileMapLayer.get cell atlas coordinates for the local coordinates that we're working off of. And finally, we need to set the alternative tile, and we're just going to do a 180-degree rotation at this point. So what we can do here is we can just take this rotate 180 and apply it here. So we're going to say tile transform, rotate 180. And we're just going to force a 180-degree rotation. This isn't going to rotate it constantly. It's just going to rotate it once, but it's going to target us a very specific tile. So if we run this, I click on it, hey, we're rotating these tiles. So we can modify that at runtime in that case. Again, notice how I click on them multiple times. We're not rotating constantly here. What we could do is read the alternative tile information, and we could kind of exclusive or apply this so it toggles it on and off if we wanted to. Now, if you notice, this line of code is actually getting quite long, so much so that I need to scroll horizontally. Because we're in parentheses here, we can actually just move to a new line. And if we indent twice just for readability's sake, this makes things a little bit easier to read, where we can see that this is the method call that we're doing. The first parameter is here, and then every subsequent parameter is just on the next line. This is purely a readability thing. If you aren't working inside parentheses in order to govern the line here, what you might need to do is put a backslash at the end of a line just to denote that, hey, we're not finishing the statement at that point. We are, in fact, allowing you to move to the next line. That just improves the readability here. If we did want to put the rotation in here, we could say TileMapLayer.get cell alternative tile. Again, pass in the local coordinates. Tile transform rotate 180. This caret symbol stands for exclusive OR. What we're using it for is to toggle this particular bit in the alternative tile on and off. This is getting into bit math, and I'm not going to cover that here, but there will be a resource in the description below that will provide you with some additional information if you want to learn more about how bit math actually works. Now, one final piece of information I think is going to be really useful is to take a given coordinate and see what your neighbors are. What do you have available to work with? And so this could be just what neighbors exist around me, but it could also mean, is there a tile to the left of me or to the right of me? So let's start with just gathering up which tiles are surrounding this particular tile. So we can remove some of this previous information here. We have our current mouse position and the local coordinates. Let's take this and just gather our neighbors up. So we want to create a new variable here that's going to store our neighbors in it. And this is going to be an array that stores vector 2 i's. Again, this is the surrounding coordinates that you have. We're going to TileMapLayer.get surrounding cells, and we pass it in local coordinates. Now, the number of values that you get from this is going to vary depending on what your tile shape is. So we are working with square tiles here. If we were working with square or isometric tiles, we would get 4 results back. And so this will always contain 4 values. If we were working with hexagonal or the half offset square tile shapes, we would get 6 values back, always. It doesn't matter if there are tiles populating those surrounding coordinates, it's just gathering those coordinates up. Now this is safer than us saying, well, let's take our local coordinates and we're going to add a vector 2 of 0 and 1 as an example. This seems like it might be okay for gathering up this information. However, when you start getting into the alternative tile layouts for isometric and hexagonal and the half offset square, the tile layouts make this non-trivial to figure out. And simply adding and subtracting 1 isn't really going to give you a consistent result. The safest way to do this is really use get surrounding cells. And in fact, the documentation even covers this, that it is handling all of this for you. So it's using existing tile layout functionality in order to cover that. So let's just print this out. Should we have it? Print neighbors, run this. So we're going to get 4 values no matter where I click. So we can see here, this was 3.9, 2.10, 1.9, and 2.8. So 4 vector, 2 eyes total. And I was clicking off here where there were no tiles surrounding it, but I'm still getting those 4 results. And again, if we were working with a hexagonal layout or a half offset square, we would be getting 6 results. Now it's up to us again to check whether or not there's anything populating those particular cells. Should we need them? Should we need that information? And we already know how to do that. We can check to see if the source ID is not -1. So this gets us the surrounding cells, but what if we wanted to just move in a direction? Let's say that I was on a given tile here and I just wanted to move 1 to the left. Well, we can easily do that with TileMapLayer.getNeighborCell. So we take our local coordinates, we pass them in. This is our anchor point. This is our starting point. And then we need to provide a cell neighbor indicator. And so this is telling Godot, hey, which direction should I be looking? Should I be looking to the left, to the right, up, down, maybe to one of my corners instead? This is something that the TileMapLayer can handle automatically for you. And this definitely takes into account the various tile layouts. And so if you've seen my videos on isometric and hexagonal layouts, you'll know that they can not necessarily be the most intuitive if you're just looking at them. Neighbor cell will take this into account. And it says this method takes into account the different layouts a tile map can make. So let's just pick a value to put in here. So we're going to say tile set.cell. I'm just going to pick an arbitrary one here. Bottom left corner. We're going to print out this information. So if I do this and I click, we're going to get values coming out of this. Great. Now, sometimes you might get errors popping up here. So if you see something that says that in your errors that you're getting P chords returned, this is a sign that you have used a cell neighbor reference that your current tile shape doesn't understand. You can always look at the C++ code. There's always a link to it that you can take a look at in the error console. And this will give you a list of which particular cell neighbor references you can actually use. So if you're working with hexagonal or isometric layouts, you are significantly limited by what you can apply there because they don't always make sense. Top left, bottom left, the top right, bottom right, these make sense from an isometric standpoint, but directly to the left, like there is no left side when it comes to isometric. So that would cause an error to occur. And these are things that Godot handles, it fails gracefully, but you can still run into issues and it's not going to operate as you would expect. Before we wrap up here, I just want to acknowledge that we've been limiting ourselves deliberately in terms of input mechanisms here. We've been using exclusively a mouse in order to interact with this, but that's not necessarily how you would be interacting with TileMapLayers. You could be using player coordinates as an example. So maybe a player moves one tile forward, and that means that we need to check if there's a movement penalty for moving into that cell. That's a very real situation that you could be working with here. That being said, the process by which you're going to translate position to local coordinates and do something with that is exactly the same as what we've been doing here. Instead of just working with an event position, we're going to be interacting with another sprite or another node's position. it's all exactly the same here. It's just a different means of retrieving a position to work off of here. So that's something to keep in mind as we've been talking specifically about mouse input, but that doesn't mean we have to be using mouse input. This was a way of getting vector 2, which was a position, and then translating that over into coordinates on the map. But we can be sourcing that from the mouse position without a mouse click. It could have to do with where your character is, or a projectile, or really anything else that you could be interacting with. So that's something to keep in mind. Very often, this is going to be a player moving across a map and then reading information as it goes to see, hey, is there a movement cost here? Should I be taking damage? Maybe stepping into this particular area means that my character height should be 3 or 4 pixels higher. That's an option to consider as well. And that's it for today. Did I miss anything? Let me know in the comments below, and I'll be happy to answer that in a future video. This code, as well as all my other code, is available on GitHub. You can take a look at the link in the description below to get access to this, and you can fool around with it yourself. Thanks very much, and we'll see you next time.